First question says, solve the simultaneous equations, and you've got x plus 3y is equal to 10, 2x minus y plus 4z is equal to 2, and 3x plus 2y minus 3z is equal to 19. First thing I would do in this question is I would call these equation 1, equation 2, and equation 3. It just makes it easier for you to explain what you're doing. Now in this one, I want to get rid of one of the unknowns, so I'm going to say eliminate, and I'm just going to abbreviate that, so eliminate x. So I want to get the same number of x's in a couple of equations, and then I can go from there and eliminate them. So what I'm going to do is I'm going to multiply my first equation by 2, so 2 times my first equation, which is going to give me 2x plus 6y is equal to 20. That was my equation, that was 2 times equation 1. And then underneath it, I'm going to write down my second equation, which is 2x minus y plus 4z is equal to 2. That was my equation 2. And if I subtract those, I will get rid of the x terms. So if we subtract them, so what I'm doing is 2 times equation 1 minus my equation 2. 2x minus 2x it disappears. 6y minus y is going to be 6y plus y, which is 7y. And then nothing minus 4z is minus 4z. And that equals 20 minus 2, which is just going to be 18. So that is how I got that. That was 2 times equation 1 minus equation 2. And also we're going to give it a new name. We're going to call it equation 4. Okay, I'm also going to eliminate x from my first equation and my third equation. So the first thing I'm going to do here is multiply my equation 1 by 3. So it becomes 3x plus 9y. I'll leave the wee gap for the z this time, is equal to 30. And then write down my equation 3 below it. So equation 3 was 3x plus 2y minus 3z is equal to 19. And again, we're going to subtract. So I'm going to do 3 times my equation 1 minus my equation 3. 3x minus 3x is 0. 9y minus 2y is 7y. And 0 minus 3z is plus 3z. And 30 minus 19 is going to give you 11. And I'm going to call that my equation 5. Okay, I've got my equation 4 and my equation 5. I'm just going to write my equation 4 below this one to see what I have got. And that's what I have. That was my equation 4. And now I've reduced this whole system down to 2 equations with 2 unknowns. So here what I'm going to do is just subtract. And if I subtract, I'm going to have 7z is equal to minus 7. A wee bit of working out then, z is equal to minus 1. Sub that back in to equation 4. Sorry, equation 4. And you will have 7y plus 4 is equal to 18, which works out very nicely. 7y then is equal to 14. And then divide by the 7y is equal to 2. So we've got our value for z, we've got our value for y. We're going to sub both of those back into, and I'll file them back into equation 1. And if you look back at your equation 1, here it is highlighted, your equation 1 doesn't actually have any z's in it, so it's just x and y, so it'll make life easier for ourselves. So what was my equation 1? X plus 3y equals 10. So that's going to be x plus 3 times the 2 is equal to 10. Which means x plus 6 is equal to 10, which means x is equal to 4. And then definitely what you should do then is just check in equation 2. And my equation 2 was, I'll just write that at the side there, 2x minus y plus 4z equals 2. 2x minus y plus 4z is equal to 2. So I'm going to check in this equation. And if we do that, we are going to have our x was 4, so 2 times 4, minus my y, which was 2, plus 4 times my z, which was minus 1. If you do that out, you're going to have 8 minus 2 minus 4. And that's going to be 8 minus 6, which equals 2, which is what we had wanted over here. So we are right. So just write down your answer. X is equal to 4, y is equal to 2, and your z is equal to minus 1. And a lovely question, because you know you've got the full whatever number of marks it's going to be. I think it was 6 marks. So it's a nice start to us. Okay, question 2, it says write 2x squared plus 4x minus 5 in the form 2 upon brackets x plus p squared minus q close brackets. So this is a completing the square question. They've made this very nice for us because they've actually written in this form where they've taken the 2 outside the bracket first of all. So there's a good clue of how we start. So 2 comes outside, leaving you x squared plus 2x minus, and then half of the 5 is 2.5. So now we just need to do the completing the square bit. So then that is going to be equal to, leave the 2, and we're going to complete the square. So in this bit in here, you half the coefficient of the x, which is just 1, so it just becomes x plus 1 squared, then minus your 2.5, and then you've got to remember to minus, that thing, half of that thing squared again. Okay, so what you have then, tidy up, that's going to be 2 upon x plus 1 squared, and 2.5 minus another 1 is just going to be minus 3.5. So that is it. We've done it the same. It's now in the same form as I wanted, so that should be 2 marks for us. Next bit says, state the maximum value of your thing, so the value of x at which it occurs. So your maximum value, I'm just going to write that again, it's 2 upon x plus 1 squared minus 3.5, and your maximum value is going to be equal to, so your minimum value, I should have said, your minimum value is going to be equal to 2 times minus 3.5, which is minus 7, and that happens when your x plus 1 is equal to 0, i.e. your x is equal to minus 1. Okay, part B of this question says, in a controlled experiment, the number of bacteria n after t hours is given by this. Find the initial value of n. So we'll just say, for this one, just put t equal to 0. Means your n is going to be equal to 500 times e to the power of 0. Anything to the power of 0 is 1, so n is equal to 500. Part B says, find in whole minutes the time for n to increase by 48%. So I'm not going to actually work this out, what an extra 48% would be, but to increase something by 48%, you'd multiply by 1.48. So 1.48 times your 500 is what it increases to. So that's what your n is equal to. So let's just write that in. So it's 1.48 times 500 is going to be equal to 500 upon e to the 2t. And then we can just work on from here. So what you can see, you've got 500 multiplying on each side, so it can just cancel out. So 1.48 is equal to e to the 2t. And then we can inverse the e by just taking lins of both sides. So ln of 1.48 is equal to 2t, which means t is equal to 1/2 times ln of 1.48. Okay, let's work that out and see what we get. So that's 0.5 times ln of 1.48 and press equals, and I've got 0.1960210439. I've just given you all the decimal places from the calculator. This was in hours, and the question asked me to find in whole minutes the time for this thing to increase by 48%. So multiply that by 60 to get your time in minutes. So that's going to be 76126.263. So it is going to take whole minutes. It's going to be, your answer is going to take 12 whole minutes. Done. This question, we've got a trig problem. It says sine brackets 2x minus 60 is equal to minus 0.5. First thing we've got to do is find our basic angle. So your basic angle, how you find it, is sine to the minus 1 of, and ignore the minus, so sine to the minus 1 of 0.5. Just check that on your calculator. So sine to the minus 1, 0.5, press equals, you get 30 degrees. So your basic angle is 30 degrees. Next thing you need to do is adjust your range. So it's not sine x, it is sine of 2x minus 60. So we're going to adjust this range over here. So multiply 0 by 2 and then take away 60. You're going to get minus 60 degrees is less than or equal to 2x minus 60. And multiply 360 by 2 gives you 720. Take away your 60 gives you 660. So we're looking to solve this thing between minus 60 and 660. So draw your cast diagram. CAS and T, I'm going to do this exactly as I would do this myself in an exam. And your basic angle was 30 degrees. Now you're looking back at this thing, it was negative. So sine is negative in here and in here. And you put your 30 degrees, your basic angle in here. And for my first one, it's going to be from here. This is your 0, remember? And I'm going to do the negative one first. So you're going to have 2x minus 60 is equal to negative 30. And if I went around this way, this would be beyond minus 60 degrees, so we're going to ignore that one. But I could I'll get rid of those, I'll get rid of that wee arrow to avoid any confusion. The next one then is going to be going the positive way. So that's going to be round to here, which would be, round to the horizontal line would be 180 degrees, another 30 would take you down to 210 degrees. And then the next one is going to go all the way around, 30 short of 360, so it's going to be 330. And then our last one, you're going to have to go all the way around again. So it's going to be round one complete turn, and then round again to here. So that's going to be 360 degrees bigger than this one basically. So add 360 onto that. So 360 plus your 210 gives you 570 degrees. Okay, now what we've got to do is solve this equation. So you've actually got 4 linear equations here. You've got 2x minus 60 is equal to minus 30, 2x minus 60 is equal to 210, 2x minus 60 is equal to 330, 2x minus 60 is equal to 570. So the first thing we're going to do is bring the 60 across. So the minus 60 comes across and it becomes plus 60, so it adds on to all of those to give you 30 degrees, 270 degrees, 390 degrees, and then 630 degrees. And then what you're going to do is bring the 2 across when now comes dividing. So you're going to have 15 degrees. You're going to have 135 degrees. You're going to have 195 degrees, and then you're going to have 315 degrees. Now just check that they're all within the original range, which was this up here, which was 0 to 360. So 15, 135, 195, 315, all within that range. So it looks as if we are good. You could as well put them back into the original equation to check. I don't think you really have enough time in an exam to do that. Do that at the end of the exam if you have time and you're just checking through your working out. Okay, part B, and this one through a few people doing this exam first time around, so just be careful on this one. It's actually a very nice wee proof. If we just look at it and approach it the way you should always approach a proof. So the way you should approach a proof is look at one side only. So clearly we're going to look at the left-hand side, as there's not much we can do with the right-hand side. So on the left-hand side, you have got tan x cos x. I'll zoom in a wee bit here. Tan x cos x over, and then you've got 1 minus cos squared. Now from the wee identity that you should know, which is sine squared plus cos squared is equal to 1. That could be rearranged. Sine squared then is going to be equal to 1 minus cos squared. So this is where this is coming from. So the bottom line really becomes sine squared to the power of a half. Now, power of a half means the square root. So the top line stays the same. Square root of sine squared is just going to be sine. So that's what we have got now. So I'm just going to write this a wee bit differently. That's really tan x times cos x over sine x. And then is there any other way we can write tan? And of course there is. We could write your tan x is the same as sine x over cos x. So that's what we'll do here. Write your tan x as sine x over cos x. And then what you can see, I'll do this in a different color pen. You can see there's a wee bit of cancelling happens here. So cos goes into itself once, cos goes into itself once, sine goes into itself once, sine goes into itself once. So you're just left with 1 over 1 times 1 over 1, which is just 1 times 1, which is just 1, which equals your right-hand side. Happy days, you know you've got it right. Okay, question 4 says, a curve is given by the equation y is equal to x squared plus x. Find the equation of the normal to the curve at the point where x equals 2. Okay, we'll get started this one. First thing I'm going to do is just write down the equation again. Y is equal to x squared plus x. If it says the word normal, it says the word tangent, it says gradient, it says maximum or minimum, any of these words, these are key words that should make you think about differentiating. So the normal, I'm going to find first of all dy by dx. Going to give me 2x plus 1. Next thing it says, so that's my gradient equation. So that is dy by dx is the gradient function. It allows you to find the gradient at any point. The point we have here is x equals 2. So we word to say when x equals 2, dy by dx is equal to 2 times 2 plus 1. So dy by dx is equal to, and that's just going to be 5. So I'll just do this up here. So we'll just say the gradient then of the normal. So that gives you your gradient function, gives you your gradient of your tangent. Your gradient of your normal is a negative reciprocal. So it's going to be minus 1/5. So my normal so far is y is equal to minus 1/5 x plus c. Okay, how we're going to find our c is we're going to find our value x equals 2. For our value x equals 2 into this equation for your y. And then that'll give you a point, which will then allow us to find our point c, our value c. So we just say when x equals 2, y is equal to, so 2 squared plus 2. So remember that was just putting it into this equation over here. And that gives you, 2 squared is 4 plus 2 gives you 6. So now what we're going to do is sub 6 into the normal equation and see what we get for our c. So when we sub that into our normal, you're going to have 6 as my y value is equal to minus 1/5 times my value x value, which is 2, plus c, which means you're going to have 6 plus 2/5 is equal to c. And I'm going to write that as a top-heavy fraction. 6 would be 30 over 5. 30 over 5 plus 2 over 5 is going to be 32 over 5. And then my normal then is, normal is going to be equal to, y is equal to minus 1/5 x plus 32 over 5. Okay, normally this would be all right to give you full marks, but read the question carefully. The next part of the question, which I don't think I read out to you, said leave your answer in the form ax plus by plus c, where a, b, and c are integers. So first of all, here we haven't got everything on the one side, and also they're definitely not integers, so we're going to have to sort that out. So I'm going to bring everything to one side. I have positive 1/5 x plus y minus 32 over 5 is equal to 0. And then to make these integers, I can just multiply through by 5, and that will give me x plus 5y minus 32 equals 0. That looks good. Let's just check if that's in the right form that I wanted. Ax plus by plus c equals 0, and that is what we have done. Happy days. Okay, part 2 says find the values of k for which the line y is equal to kx minus 4 is a tangent to the curve. Okay, so we're just going to say, first of all, this is a discriminant question. So you've got 3 options when you've got a curve. If I say I had this curve here, U-shaped curve, then I have a line. First thing, it could cut it twice. It could maybe not cut it at all, or you've got your curve and it is a tangent to it. So in this case, your discriminant b squared minus 4ac is going to be greater than 0 for this one, because there's 2 solutions. This one, b squared minus 4ac, is going to be less than 0 because there's no real solutions. And the last one here, b squared minus 4ac is going to be equal to 0. So I think that's what we're looking for. Tangent, yep. So we're in the last situation. That's what we're going to do. Okay, just get rid of all that. You wouldn't put that in an exam just to explain what we're doing in this question. So what we're going to do first of all is we're going to put these two equations equal. Equal to each other, really, I should say, but I haven't done that. So just say x squared plus x is equal to kx minus 4. And then we're going to bring it all to one side. So you're going to have x squared plus x minus kx plus 4 is equal to 0, which means x squared plus 1 minus k, x plus 4 is equal to 0. And we'll put a wee note in, just say if a tangent, you have b squared minus 4ac is equal to 0, which means 1 minus k squared minus 4 times my a, which is 1, times my c, which is 4, is going to be equal to 0. And if you square out this 1 minus k, you're going to have k squared minus 2k plus 1, and over here minus 16 is equal to 0. Tidy that up, you're going to have k squared minus 2k minus 15 is equal to 0. And then that factorizes to give you k minus 5 upon k plus 3 is equal to 0, which means k minus 5 equals 0, which means k is equal to 5, or k plus 3 is equal to 0, which means k is equal to minus 3. I think that's this question done. It is indeed. Happy days. Okay, question 5 says integrate, and we have 5x to the 4 plus 1 over 2x cubed minus 4 over root x. First thing you want to do is rewrite this in index form. So you're going to write it as 5x to the 4 plus 1 half x to the minus 3 minus 4 x to the minus 1 half. And then you're good to integrate. You've got an index form, you're good to go. So integral of 5x to the 4 plus 1 half x to the minus 3 minus 4 x to the minus 1 half integrated with respect to x. Integration, remember, raise the power by 1 divided by the new power. So it's going to be 5x x to the 5 divided by 5, which is going to be x to the 5. And x to the minus 3 plus 1 is x to the minus 2. And dividing by the minus 2 is going to actually give you minus 1 quarter. And then add 1 to minus a half, it's going to give you 1 half. And minus 4 divided by a half is going to be minus 8. And remember your c, your constant of integration. Okay, haven't seen the mark scheme at this stage, but I would imagine because I've given the question in this form, they want you to give the answer in that form as well. And this is where a lot of people will get into trouble. So x to the 5. Just going to show all really what's going on in my head. X to the minus 2 is 1 over x squared. And you have minus 8. And x to the half is just a root of x plus c. So it's only really this middle term we've got to worry about. And if you have your x, your 5, you've got your minus 8 root x, you've got your plus c. So here, what you want to do is just multiply along the top. 1 times 1 is just 1. And then multiply along the bottom. 4 times the minus x is 4 times the x squared is 4x squared. And that is it. That's as nice as we can make it. Next part of the question says, given that the integral from minus 1 to 2 of x squared minus px plus 3 is equal to 8, find the value of p. So the first thing we're going to do is integrate the left-hand side. So it's now going to become a square bracket, x cubed over 3 minus px squared over 2 plus 3x. And that's between 2 and minus 1, and we know it equals 8. So we're going to have two square brackets. Put in 2 first of all. 2 cubed is 8, so 8 over 3 minus 2 squared is 4, divided by 2 is just going to give you 2, so it's going to be minus 2p. And then 3 times the 2 gives you the 6, that's your first square bracket. Second square bracket, put minus 1 in. Minus 1 cubed is minus 1, and that's over 3. Minus 1 squared is 1, so that's just going to be minus p over 2. And then minus 3, and that still is equal to 8. And we need to tidy this up. So I'm going to look at the fraction bit first. That's the tricky bit. You have got 8 thirds minus 1/3, which is 1 third plus 1/3, which is 9 thirds. And then you've got the p bit then. You've got minus 2p minus a half p, which is going to be minus 2p plus a half p, which is going to be minus 1.5p. I'm going to write that as 3p over 2. And then the whole number bit, I suppose we could call it. We've got the plus 6, then minus 3, which is going to give you plus 9, and that equals 8. Okay, tidy that up, it's a bit of a mess. That's just 3 minus 3p over 2 plus 9 is equal to 8, which means 12 minus 3p over 2 is equal to 8. I'll swap the 8 and the minus 3p over 2 across, and we will have 4 is equal to 3p over 2. Multiply across by the 2, you're going to have the 8 is equal to 3p, which means 8 divided by 3 is equal to p, so p is equal to 2 and 2/3. Question 6 is a factor and remainder theorem question. It says f of x is equal to q x cubed minus 7x squared plus r, where q and r are constants. It says, first of all, f of x has a factor of x plus 1. And it says when f of x is divided by 2x plus 1, the remainder is 7. Okay, we're going to use this wee bit first of all. And that tells you if f of x is a factor, that means if x plus 1 is a factor of f of x, that means f of minus 1 is equal to 0, which means then 0 is equal to, put minus 1 through this, you'll have q times minus 1 cubed minus 7 times minus 1 squared plus r, which tidies up to be minus q minus 7 plus r, and I'll bring all the q and the r to the other side to have positive q minus r is equal to minus 7 ... equation 1. You can probably guess where this is going now. It's going to be simultaneous equations. Next bit of information to look at is this one here. It says when f of x is divided by 2x plus 1, the remainder is 7, which means f of minus 1/2 is equal to 7, which means 7 is equal to, if you put minus a half through your f of x, you'll have q times minus a half cubed minus 7 times minus a half squared plus r. And take a wee bit more work to tidy this one up. You're going to have 7 is equal to, and that's going to be minus q over 8, and minus a half squared is going to be 1/4, so it's going to be minus 7 over 4, and then plus your r. Multiply through by 8 would be the easiest thing to do here. So multiply through by 8, and you're going to have 56 is equal to minus q, and then minus 14 plus 8r. And again, we'll bring all my q's and my r's across to the other side. So I'll have q minus 8r is equal to minus 14 minus 56, which is going to be minus 70. So let's tidy up my minus, that's a mess. So there we have it, there's your two equations. So you have two equations and two unknowns, which you can now solve. And they've been very nice to us here. If you look how nice these are. We've got 1q in both equations, so we're just going to subtract. So I'm just going to do equation 2 minus equation 1. I always just do whatever one's on top minus the one on the bottom. Q minus q is 0, minus 8r minus r is going to be minus 8r plus r, which is minus 7r. And then minus 70 minus 7 is minus 63. And then your r is just going to equal to minus 63 divided by minus 7. So your r works out to be positive 9. So you've got your r. We'll sub it into equation 1, and then you'll have q minus r, which is now 9, is equal to minus 7, which means q is equal to minus 7 plus 9, q is equal to 2. So you've got your, you've find the values of r and q and r, and we've got them. R is equal to 9, q is equal to 7. Next thing says, factorize fully the expression f of x. First thing I'm going to write down, what is my f of x now? I've now got my value of q and r. So f of x is going to be equal to q x cubed. So that's going to be 2x cubed. So I have a very bad memory here. Minus 7x squared plus my r. And my r was 9 minus 7x squared plus my 9. Right, factorize fully the expression. So do not go through the factor theorem to do this. You already know one thing which divides into it, so one thing which is a factor, and that is this. Okay, so you know f of x has a factor of x plus 1. So you know x plus 1 divides into this thing. So it's polynomial division is what we want to do. So x plus 1 divides into this. You've got your 2x cubed minus 7x squared. Leave your term, leave a gap where your linear term, your x term would have been, and then you just want to divide in. So how many times does x go into 2x cubed? It goes in 2x squared times, and then multiply 2x squared times your x plus 1. You'll have 2x cubed plus 2x squared, and then subtract 2x cubed minus 2x cubed is 0, minus 7x squared minus another 2x squared is minus 9x squared, and then bring down this term. I know there's no term there, but pretend that you're bringing it down. And then x goes in, you're looking how many times x goes into this thing. X goes into 9x squared, minus 9x squared, minus 9x times. So minus 9x times this whole thing gives you minus 9x squared minus 9x. And again, we subtract. And if you subtract 9x squared minus 9x squared, they disappear. And then 0, this is really, minus 9x is 0 plus 9x, which gives you positive 9x. Then your next term comes down, and x goes into the 9x 9 times, and 9 times the x plus 1 gives you 9x plus 9, and subtract, you get 0. If this is not a 0, you've done something wrong, because you're told in the question that x plus 1 is a factor, so it really should be a 0. There should be no remainder. Okay, what's our story so far then? You know your f of x is equal to x plus 1 times 2x squared minus 9x plus 9, and we want to see if this bit factorizes. So here, I'll just do this over to the side then. We have 2x squared minus 9x plus 9. I'll just do my sum and product for this. My sum is minus 9. My product is 18, and my two numbers that work for this are minus 3 and minus 6, because minus 3 times minus 6 gives you 18, and minus 3 plus minus 6 gives you minus 9. So I can rewrite this as 2x squared minus 3x minus 6x plus 9. Factorize the first two terms completely. You'll have 2x minus 3. Factorize the next two terms completely. You will have 3 upon 2x minus 3 upon, let's try that again. You will have minus 3 upon 2x minus 3, and then write down your common bracket, which was 2x minus 3, and then your other thing was, other bracket's going to be x minus 3. So we now know how to factorize this whole thing completely. So f of x is equal to x plus 1 upon 2x minus 3 upon x minus 3. Let's just read the question again, see how we answered it. Factorize fully the expression, and we have factorized it fully. Lovely. Okay, the last part of this question is a bit strange. It says, hence solve 2x 2 upon 2 to the power of 3y minus 7, 2 to the power of 2y plus 9. Right, how this is labelled is very important. It's labelled part 3, which typically means it refers back to something you've already done in the question. And also the hence really is a big clue that it's doing that as well. So let's have a look and see how could this thing possibly relate back to what we have just done. So you've got 2x cubed. You now know your f of x is equal to 2x cubed minus 7x squared plus 9. And here we've got 2 times something minus 7 times something plus 9. So it is fairly similar if you just say let 2 to the power of y equals x. I'll call this equation 1. Then rewrite equation 1 as then it's going to be 2 times that's going to be x cubed minus 7 x squared plus 9 is equal to 0, which is what we know our f of x is equal to. And more importantly, in part 2, we know how to factorize our f of x. So this thing then could then factorize to be x plus 1 upon something else. My memory's so bad I have to look back up and see what that was. X plus 1 upon 2x minus 3, x minus 3. Okay, and then we can then solve this. So that means x is equal to minus 1, or it means 2x minus 3 is equal to the first one means x plus 1 equals 0, or 2x minus 3 equals 0, or x minus 3 is equal to 0, which means x is equal to minus 1. Over here it means x is equal to 3 over 2. Over here it means x is equal to 3. Now, if you have it, write these back in terms of the y. So it's 2 to the power of y is equal to minus 1. 2 to the power of y is equal to 3 over 2. And 2 to the power of y is equal to 3. Now, this one is impossible. So IMP just write, and they will understand that means impossible. And that is because there is no number that you can raise 2 to the power of such that it will become a negative number. It's always going to be positive. If you think back to what that graph would look like, 2 to the power of something would look like this. It's never crossing, going underneath the vertical axis, so it's never going to be equal to a negative. So that is impossible. Happy days. If you didn't know that, you could just try doing what I'm going to do in the next step, and you would see it would mess up in your calculator, come up as a maths error, so you would soon find out it was impossible anyway. What we're going to have to do is take logs of both sides here. So y ln 2 is equal to ln of 3 over 2, which means y is equal to ln of 3 over 2 divided by ln of 2, and then whatever that works out to be. I'm just doing this in my calculator very quickly here. So what have I just said? Ln of 3 over 2, which is 1.5 divided by ln of 2. Press equals, and I've got to 3 sig figs, 0.585 to 3 sig figs. And over here for this one, same idea, take lns. Y ln 2 is equal to ln of 3, which y is equal to ln of 3 divided by ln of 2, which means y is equal to, I'll go ahead and just change my values in my calculator, so it's now ln of 3 divided by ln of 2, press equals, and I've got y is equal to 1.58, and that's the 3 sig figs. Question 7 says, write down the first 4 terms in ascending powers of x and expansion of 2 minus x to the power of 8. So this is our binomial question. We have got 2 minus x to the power of 8. I'm going to say my first term then is going to be 8c, and I'm going to start with 0. But the 2 is to the power of 8, and then the minus x is to the power of 0. My next term is going to be 8c1, so 2 to the power of 7. So as that power decreases, the other power increases. 8c2 times 2 to the power of 6 times minus x squared. 8c3, 2 to the power of 5 minus x to the power of 3. So write down the first 4 terms. So that would be our first 4 terms done. We just now need to work those out and see what we get. So it's just a calculator exercise. 8c0, don't need to do on my calculator, it's just 1 times 2 to the power of 8. And 2 to the power of 8, I will just do just to check. 2 to the power of 8 is going to be 256. Anything to the power of 0 is just going to be 1. My next term then is 8c1, which is just going to be 8. 2 to the power of 7. 2 to the power of 7 is going to be 128 times minus x. And then I've also got my next term is 8c2. 8c2 is 28. And then times my 2 to the power of 6. 2 to the power of 6 is 64. Then times minus x squared. So square the minus, it becomes plus, and then x squared is just x squared. And then the 8c3 is going to be 56. Times 2 to the power of 5 is going to be 32. And minus x cubed is just going to be minus x cubed. I'll put that in a bracket. And there we are. We can just tally that all up. 1 times 256 times 1 is 256. Then 8 times 128 is 1024. And sorry, that should be minus, as it's minus that times x. The next one is 28 times 64 is going to be 1792 x squared. And then we have 56 times 32, and that's going to be minus of 1,792 x cubed. Okay, read the question. Is there anything else we need to do? Write down the first four terms and ascending powers of x. That's it. Done. Okay, bit weird this question. It's a bit of an odd way from the ask us question. It's not the finding in the independent term independent of x is not unusual, but normally they don't tell you that it's equal to something. So a wee bit different, but if you understand what you're doing, this will not be any more difficult. We're just going to say the general term equals. So we're looking at the general term and the expansion of this. So the power of the bracket is 10. So I'm going to write that as 10 CR. R is my general term. And I'm going to write this as, this is just, we'll write it as root x. The minute root x to the power of, and I'll say it's 10 minus r times minus k over x squared to the power of r. So that's an absolute mess. We need to tidy that up. So we still have our 10 CR. X to the power of, x square root of x, I'm going to write it as x to the power of a half. 10 minus r. And then I'm going to separate out the constant here from this. So I'm going to write that as minus k to the power of r. And then that's then times x to the minus 2 to the power of r. So I'm going to write that as 10 CR. X to the power of a half raised to the power of 10 minus r is going to be times x to the power of 5 minus a half r. And then I'll put the x term next to it. It's going to be x to the power of minus 2r. And then you've got your minus k to the power of r. Still tidying. We're going to have 10 CR. And then we're going to multiply these two terms together here. So they're going to become just a single x to the power of, x to the power of. And it's going to be 5 minus a half minus 2, half minus half r minus another 2r is going to be minus 2.5r. And then we have minus k to the power of r. So if it's a term independent of x, we want to put the x power equal to 0. So 5 minus 2.5r equal to 0, which means 5 is equal to 2.5r, which means we better working out r is equal to 2. So you've got your r equal to 2. So if you put r equal to 2 into this thing, you will find a term independent of x. So we'll say term independent of x is going to be equal to 10c, and your r is now 2, times, that's going to be x to the power of 0, and then you're going to have your minus k squared. So 10c2, if we do that in the calculator, 10c2 is equal to 45. And then minus k squared is going to be k squared. And that's what we've got. Okay, read the question again, see if we finished. It says, term independent of x is this thing. So we actually know it's equal to 405. So we're going to say put 405 equal to 45k squared. Divide across then 405 divided by 45 is going to be equal to k squared. So 405 divided by 45 is going to be 9. So 9 is equal to k squared. So k is equal to plus or minus the square root of 9. So your k works out to be plus or minus 3. And that is as good as we can go. Okay, question 8, it says 0.7 to the power of x is less than 5. So it's 5 marks for this question, and I'm really not too sure where they're giving the marks because there's not an awful lot to this one. But what you want to do here is take logs of both sides. I'm just going to use ln. So ln x ln of 0.7 is less than ln of 5, which means x, and if you divide across by your ln of 0.7, so x was less than ln of 5 divided by ln of 0.7, but you've got to be very careful that you change the sign of the inequality, and that is because ln of 0.7, if you do it on your calculator, I'll just do this to get you an exact value of it. If you do ln of 0.7, you get minus minus 0.357 sig figs. Okay, so that's what it is. So remember, if you multiply or divide across the inequality sign, you must by a negative number, you must change the direction of your inequality. So if we go back to this, we've got x is greater than ln of 5 divided by ln of 0.7, which means x is greater than, and we'll just work it out, ln of 5 divided by ln of 0.7, and that means x is greater than minus 4.51, and that's the 3 sig figs. So where they get the 5 marks from, I do not know. I'd imagine you'll get a mark here, maybe 2 marks for this bit of understanding, and then a mark to get the numerical value. I do not know where I'm getting the other mark for. Okay, next one, question 8. This really confused a lot of people throughout the country, really. This one, for whatever reason, really threw people. It says, find the maximum area of a rectangle which can be inscribed in the closed region bounded by the curve on the positive x-axis. If I'm honest, I've never seen a question like this, but when you look at it, it's actually a very nice question. It says maximum area. Now, if you remember back to your calculus, your dy by dx, one of the things it's used for is to maximize or minimize problems. So I'm going to expect this to be a dy by dx problem, or something along with a differentiation problem anyway, in some way, shape or form. So when it's saying maximize, I would be having that in my head, really. So you've got this rectangle here. This rectangle has an area. And what would the area of that rectangle be? We know this horizontal is x, and you know this vertical is y, because of this point here, which is xy. So the area of that rectangle is x times y. Also, we know what y is in terms of x. Y is equal to 8 minus x cubed. So your area really is x upon 8 minus x cubed. So if you just multiply that out, your area is equal to 8x minus x to the 4. So it said find the maximum area of a rectangle which can be inscribed. So we want to basically maximize this thing here. So we're going to find dA by dx first of all. So if you differentiate it, you'll get 8 minus 4x cubed. And then we're going to maximize something, you've got to put dA by dx in equal to 0, which then gives you 8 minus 4x cubed is equal to 0, which gives you 8 is equal to 4x cubed, which gives you 2 is equal to x cubed, which gives you x is equal to the cubed root of 2, I should have said, cubed root of 2. Now, how you confirm that something is a maximum or a minimum is you do your d2a by dx squared. So if you work out your d2a by dx squared, you'll get minus 12x squared, and then we'll just say when x equals the cube root of 2, d2a by dx squared is going to be equal to minus 12 times cube root of 2, which is less than 0, therefore it is a maximum. Okay, read the question again, see if we've done it. We know it's a maximum, but it says find the maximum area, so we're going to have to put it into this equation here. We're going to put your x value into this equation to find your area. So my area is going to be equal to, in fact, I'll not put it in that equation at all. I'll put it into the one above that. So I'll just highlight it. This equation here would be the one I'm going to put it into. So what's that say? A is equal to x upon 8 minus x cubed. X upon 8 minus x cubed. So we'll just say when x is equal to the cube root of 2, area is going to be equal to the cube root of 2 upon 8 minus the cube root of 8. Cubed root of 2 cubed is just going to give you 2. So that really is going to be 6 times the cube root of 2 overall. And then I'll just do that on my calculator to see what I get. 6 times the cube root of 2, press equals, and I have got 7.56, and that is to 3 sig figs. So hopefully that is right, and that is it. Okay, this is the last question exam, question 9. It says, figure 2 below shows a sketch of a circle with centre P, which is 1, 1. So you've got your centre here, you've got a tangent, which goes down here, and if that's a tangent then, that means that the angle between the tangent and radius is 90 degrees, so that's going to come into play, no doubt, in this question. Okay, what the question asks you to find is tangent to the circle at the point Q, which is 4, 3, cuts the y-axis at some point R, and it says find the area of this triangle. So to find the area of a triangle, the formula for the area of a triangle is a half base times height. So here I've got a base, and if I could find that height there, the perpendicular height, then I could find the area of that triangle. So basically what I need to do is find the length from R to Q and also the length from P to Q, and then I can do this question. Okay, we'll do the easy bit first. We'll find PQ. So length PQ, I've got that on the screen and we can still see it. So length P to Q is just going to be equal to the square root of 4 minus 1, so that's your x difference squared plus your y difference squared. And if you do that out, you're going to have 4 minus 1 is 3, 3 squared is 9, 3 minus 1 is 2, 2 squared is 4, 9 plus 4 is 13, so the square root of 13. So that's the easy bit done. The hard bit now is to find the length of QR. So from Q here up to the R. We've got to find this point R. First thing I notice is I could find the gradient of this thing. So if I find the gradient of this line here from P to Q, then I can find the gradient of this line, and then I could sub in this point, and then I would be able to find the equation of my line R to Q. So a bit of a mess there, but that's what we're going to do. So we're going to find the gradient of PQ first of all. So gradient PQ, remember y difference. So 3 minus 1 over 4 minus 1 is equal to 2 over 3, which tells you then, therefore, the gradient of your tangent is a negative reciprocal of that, so minus 3 over 2. So that's what your gradient of your tangent is. So we have got the gradient now of this line here, this line here, that's the gradient we have. So if we sub in this point, we should be able to find the equation of that line as well. So we're going to sub in our Q. So our tangent so far is, remember, no, y equals mx plus c form. Y equals 3 over 2x plus c. And we'll sub in our point, what do we call it, Q, which was 4, 3. So if you sub in Q, you're going to have 3 is equal to minus 3 over 2 times the 4 plus the c. So that's 3 is equal to, that would be minus 6 plus c. Wee bit of working out, your c works out to be c. So your equation of your tangent is y is equal to minus 3 over 2x plus 9. So at your point R, so at R, your x value is equal to 0. So y is equal to 0 plus 9. So y is equal to 9. So your point R, we have just worked it out to be 0, 9. So we're now ready to find, we've got your R is 0, 9. We're also ready to find the length of RQ then. So length RQ, let me just write down what my Q was. Remember it was 3, 4. It was 3, 4, wasn't it? No, it wasn't. It was 4, 3. A wee bit easier for you to do this when you've actually got the paper there. You don't have to keep flipping up and down. So you've got your R is equal to 0, 9 and your Q is equal to 4, 3. Your length then is a y difference. So I'm going to go for 9 minus 3 squared plus the x difference, so 0 minus 4 squared, and then square root of all that. So that's going to be 9 minus 3 is 6, 6 squared is 36, and then 4 squared is going to be 16, so that is going to be root of 52. So your area of the triangle, and let's just think it is a half times base times height. And let's just go back and see what we've actually got. We've now got this length, remember, we've got this length, so we've got the base and the perpendicular height, so we can just put those in. So it's a half times our base, which was root 13, times our height, which we've just worked out to be root of 52, and if you do that, you will get 13 units, and squared as its area. Just scroll down slowly through all of that, what we've done. Okay, very last part of this question. It says, figure 3 below shows a sketch of a right angle triangle ABC, and it says AB has length root of 3x minus 1, BC has length of 2 root x, ABC is equal to theta, given that cos squared is equal to 1 over x, find the value of x. So, you have got, we've got to find, it says cos squared of something is equal to 1 over x, but also I could find that cos theta is equal to, remember what cos is equal to, it's adjacent, which is AB over AC in this case. So that's what we could use as well. So it's AB over AC. So if we need to find our AC first of all. So your AC squared then by Pythagoras is equal to the square root of 3x minus 1 squared plus 2 root x squared, because AC is a hypotenuse, so AC squared is going to work out to be 3x minus 1, and then square this bit is going to be 4x, so tidy it up, you're going to get your AC squared is equal to 7x minus 1, which means AC is actually equal to the square root of 7x minus 1, which tells me then cos of theta, remember it was equal to your AB over your AC, so it's going to be root of 3x minus 1 over root of 7x minus 1, but also cos squared theta, is equal to 1 over x. Therefore, that 1 over x could be equal to this thing squared. So if you square that, you're just going to get 3x minus 1 all over 7x minus 1. And then what you could do is cross multiply. So you multiply in that fashion, you'll have 7x minus 1 equals 3x squared minus x. Bring it all to one side, put it equal to 0, 3x squared minus 8x plus 1. And then we could tidy that up in some way, shape or form. And well, no, we can't do anything with that. Sorry, I was going to say we could factorize that, but we can't factorize it. We'll have to use our quadratic formula. So it's going to be minus b, which is 8, plus or minus the square root of b squared, so minus 8 squared, minus 4 times my a, which is 3, times my c, which is 1, all over 2a, so that's 2 times 3. That needs a bit of tidying up there. So that's going to be 8 plus or minus the square root of square root of that thing. If you put that into your calculator, you'll get 2 root 13. And then that is divided by 6. And then again, that tallies up to be 4 plus or minus root of 13 divided by 6. No, divided by 6 divided by 3. And that is